In this presentation, we will talk about application of metrics. This is MD Shahriar Khanimon presenting this topic, and my another teammates are Mizanur Rahman, Fahim Hussain Shuman. This topic is submitted to Muhammad Jahid Hassan, lecturer, Department of Tripoli, University of Chittagong. I would like to start the covering by the question, what is metric? In mathematics, a matrix is a rectangular array of numbers, symbols, or expressions, mainly datas, arranged in rows and columns. Think of it as a table of values organized in specific way. The individual items within the matrix, it can be the numbers, it can be the symbols, or it can be the expressions or datas, are called its elements or entries. Let's discuss about some important types of matrix. They are square matrix, zero matrix, identity matrix, inverse matrix, and so on. Now, I will dive into our core topic, which is applications or real-world appliance of matrix. First of all, computer graphics. In our day-to-day life, we all uses computer, but we even don't know that the matrix are using behind those scenes. Using matrices in the computer graphics field for representing 3D objects on a 2D screen, rotation, translation, scaling, etc. As you can see in this video, I am representing another example of 3D scaling, representing and rotation of the 3D objects in a 2D screen. The second applications is solving linear equations. Some systems of our real world which uses linear equations. This linear equation solved by using matrix methods like Gaussian elimination and Cramer's rule, etc. The third thing I will discuss from all the applications of matrices is big data analysis or data analysis. The application of matrices in the data analysis will be explained soon. In big data analysis, their structured format allows for efficient storage and manipulation of large datasets. Matrix operations rooted in linear algebra enable concise execution of complex calculations essential for various data analysis techniques. Metrics are crucial for solving linear equation systems, performing linear transformation or dimensionality reduction like PCA and SVD, and facilitating feature engineering. They also play a key role in representing relationships in network and processing image and signals. In this era of artificial intelligence and machine learning revolution, what is the impact of metrics in these machine learning calculations and artificial intelligence algorithms? We'll discuss in later slides and in a details way. Metrics are absolutely fundamental to artificial intelligence and machine learning. They serve as the primary way to represent and manipulate data, which is the lifeblood of these fields. Here is a summary of their key applications. Data representation. Metrics are used to represent datasets where row typically correspond to individual data points and column represents features or variables. This structured format allowed efficient processing. Linear algebraic operations. The core computation in artificial intelligence and ML algorithms rely heavily on linear algebra operations performed on matrices. This include addition, subtraction, multiplication, transportation, inversion, and decomposition, which are essential for tasks like model training, prediction, and evaluation. Model parameter storage. This weights and biases many AI/ML models, especially neural networks, are stored and updated as metrics. Matrix operations are used to perform forward and backward propagation during training and etc. That's we are called vector dynamics and vector representation in the LLM models. Metrics play a significant role in networking, primarily as a powerful tool for representing and analyzing network structures and relationships efficiently. Here is a summary of their application: adjacency matrix. This is fundamental applications where matrix represent the connection within a network. Each row and column corresponds to a node. The entry at ij indicates whether there is a direct connections or no direct connections between node I and node j. Incidence matrix, another matrix representation where the row represents nodes and column represents edges. The entry indicates the relationship between node and the edge. If the node is the endpoint of the edge, -1 if the starting point of a direct graph, 0 otherwise. Routing tables. While not always explicitly stored as a single large matrix, the concept of routing tables, which indicates the path that a packet takes, can be viewed and manipulated using metrics-like structures. Network analysis. Matrix operations can be used to analyze network properties. For example, powers of adjacency matrix can reveal the number paths of a certain length between nodes. Eigenvalues analysis of a network matrix can provide insights into network stability and community structure, etc. In display technology, the term matrix fundamentally refers to the organized grid of the pixels that makes up the screen. The grid structure controlled electronically is what allows displays to form image, text, and video. Here is a breakdown of how metrics are relevant in display technology. Pixel arrangement, the core of the display technology, or any other displays like LCD, LED, OLED, etc., is a matrix individual picture elements or pixels. The pixels is arranged in row and columns. The resolution of a display is determined by the number of pixels in the matrix, like 1920 times 1080 indicates the matrix with 1920 columns and 1080 rows. The higher resolution means the denser matrix with more pixels. Addressing the control. Each pixels in the matrix needs to be individually controlled to display to the correct color and brightness. Different matrix addressing schemes are used to achieve this. First of all, passive matrix. In order to some simpler displays, pixels are addressed by sequentially scanning rows and columns. This method is cost effective but suffer from slower response times and lower brightness. Some basic LCDs and PM OLEDs are the examples. Active matrix. Modern high performance displays almost universally use active matrix technology. In this method, each pixel can control by its own dedicated switching elements, typically a thin film transistor or TFT display technology. This allows for the faster response times. New and modern technologies of displays like LCDs, MLCDs, or active matrix LCDs, AMOLEDs, or the active matrix organic light emitting diodes are used by these matrix technologies. In this whole presentation, I tried to cover the whole applications of the matrices in our daily to daily life and the real world and technologies. Thanks for watching.